Now, because we want a little bit of a challenge, let's see if we can graph an ellipse written in a form that looks a little bit different than standard form, meaning that we have a translation. So far, we've been looking at ellipses that have an origin or a center spot right in the middle at 0, 0. But not all ellipses are at the origin or 0, 0. They're going to be shifted all around. So how do we understand what that shift looks like? How do we understand where its new center point is at? And how we understand that is we imagine that we're going to add or find out how far away along the x-axis or along the horizontal axis is a new center point, and we call that our variable h. And then likewise, vertically, what's the vertical difference between our 0 and the new point? And we label that as a k. So we would have some new equation that's involved in translation as x minus h squared over a squared plus y minus k squared over b squared equals 1. And that helps us to understand that we have an ellipse. This is still ellipse in form. We have some top term squared divided by a squared plus some y squared term divided by b squared equaling 1. So that's a standard form of an ellipse with a translation, meaning that its center point is not at the origin, it is somewhere else. So imagine if the origin was 0 in this one, where h and k were 0 distances away from the origin. This would just result down to just x squared, a squared over or plus y squared over b squared. And so both those equations are the same. This one's just evaluated where h and k is 0. So what we have up here then, we need to identify, one, that it's an ellipse. It's an ellipse in standard form. It's equaling to 1. We identify then where is the new center point. What is h and a k? So to do that, we need to get it in this particular form exactly, and it's not quite there. We do have an x minus 1 that's in the correct form. But the y plus the 2, we need it in a y minus a k. So I need to rewrite y plus 2 as y minus a negative 2. See what I did there? A minor difference. It was a minor change, and it was a subtle change, but we needed to do that so we identify exactly what the h and the k are. So h now is specifically a 1. K, since it's y minus k, k is now a minus 2. All right, from there I think we have enough information. Which one is its major axis? Is this a vertical or horizontal? Well, the major axis is one with a larger number on the bottom, larger numbers underneath the y, so it is elongated along the y-axis. So this represents my a squared, and this one's my b squared. So a then would equal 3, and b equals 4, 2. And then lastly, we need to figure out what c is. So c squared, we know what c squared was, is a larger term squared, so it's a 9 minus a 4. And c equals root 5. All right, we have all the information I think that we need in order to provide a nice graph of this one. So it translates over 1 and down 2. So let's go ahead and just start to draw a grid. We have a new center point. Before we do that, try to do a good scale so my ellipse looks like an ellipse. All right, so we have a new center point at HK, which is over 1 and down 2. So that's my center point. From there, we know that my major axis is a vertical one, which means it runs parallel to the y-axis. And my vertice is at 3 units above the center, not at the point 3 and 0, or 0 and 3, but 3 points above the center point, 1, 2, and 3. That's an important distinction to remember. And likewise, this A represents the distance from the center, not from 0, 0, but from the center as 3 points down. So there's my two vertices along the major axis. My minor axis are 2 points away from the center. So this point would be over 3 and down 2. This point would be over backwards 1 and down 2. This one's up at 1 and 1. And this one's down over at 1 and down 3, 4, 5, 6. So there's all the vertices of this particular one. Let's go ahead and do my best job to try to graph what appears to be an ellipse. And then we're left to figure out where the foci are. Foci are root 5 units above the center along the major axis. And root 5 is a little bit more than 2. So it looks like it's right about there and right about there are the two foci. The positions of those, this one up here is at the point 1. It's over 1, and it is up from -2 plus a root 5 is the position of that y coordinate. And this one down here is at 1 and -2 minus root 5. Since the distance from the center point is root 5 away, my center point is -2. I've subtracted another root 5 from that. It drops it down to there. And so that's probably the best description of where exactly those foci are at. So how do you feel? Do you feel all right again about how we can translate and just move a graph around? So the key points is let's identify what the true h and k are, the true new center. So we have to make sure we have it in the form where it's an x minus an h and a y minus a k. That trips up a lot of people. Secondly, let's figure out which one the major axis is. Major axis this time was on my y. That was my larger value. So that means it's a vertical ellipse that's parallel to the y-axis. And then from there, find our new center point and then create the new center point and use that as we figure out how many units above, below, side to side are my A, B's, and my C's.